Hello students and welcome to my channel Maths Hub. I'm Dr. Tanya Bose and I will be talking to you about the Fourier transforms today. So now what are Fourier transforms basically? Fourier transform was named after Joseph Fourier, who was a mathematician, and it is a mathematical transformation to transform the signals between the time domain and the frequency domain. So Fourier transform, it provides a continuous frequency resolution of a function. It is useful in the study of frequency response, solution of partial differential equations, discrete Fourier transform, fast Fourier transform in signal analysis. So basically, it is a tool that breaks a waveform into an alternate representation characterized by sine and cosine functions. So you can see that it is, so if this box represents a tool, so whenever we put a function fx into it, if the input function is fx, then after applying the tool, we get back the function ft. Similarly, if we have to do the inverse of it, that means if the function ft is given to us and we apply another tool, which is known as the inverse Fourier transform, then we get back the function fx, right? So we can say that it is a mathematical tool that helps to break a waveform into a sum of sinusoidal functions. So now, so you can see the applications here. So you can see that the frequency, this is the waveform in the time domain. And when we apply the mathematical tool, that is the Fourier transform, this waveform in the time domain gets converted to a waveform in the frequency domain. Now you might be imagining that where these can be used. They can be used in image recognition, in speech recognition, right? So everywhere where we have to study the signals, we can use these mathematical tools. So it helps you to visualize the signal between the time domain and the frequency domain. So now let us see that how do we get these Fourier transforms from the Fourier series. So I will request you that if you haven't watched my videos on Fourier series, do watch them because Fourier transform is derived basically from a Fourier series. So let us do the derivation part and see how to get it. So we assume that there is a function f of Lx in the domain minus L to L. So we will assume that the function flx is working in the domain minus L to L. So if I have to write its Fourier series, we will write it as FLX is equal to, we know that the Fourier series is represented by these coefficients A0 by 2. Then we have summation n going from 1 to infinity an. Then we have cos n pi x by L plus summation n going from 1 to infinity bn sine n pi x by L, right? So we know that this is our Fourier series. So let us make a substitution. Let us put Sn is equal to n pi by L, right? We are assuming the substitution and let us put the substitution here. So when we put the substitution, we will get A0 by 2 plus summation n going from 1 to infinity an cos. So n pi L will get converted to Snx plus summation n going from 1 to infinity bn sine. Again n pi by L will become Snx, right? Now let us put the values of these coefficients, that is A0, An and Bn. Now we know that whenever we are working in the domain minus L to L, the value of A0 will be 1 by L. So there is a 2 already there. So we will get 1 by 2L. Integration from minus L to L. Then we integrate the function flx dx plus then we have summation n going from 1 to infinity. An is 1 by L integration minus L to L flx into we have cos snx dx, and this is the value of an, right? And then we have also cos snx. Clear? Similarly, we put in the value of bn, so we will get summation n going from 1 to infinity. Bn is 1 by L integration minus L to L flx. Then we have sine Snx dx. So this is the value of Bn. And then we have here sine Snx. Clear? So I hope this step is clear to everyone. So now let us take the limiting case when L approaches to infinity, right? So let us assume that what is the shift in Sn? So I'll just work it out here. So we know that delta S, the change in Sn would be Sn plus 1 minus Sn. So if your Sn is n pi by L, so Sn plus 1 will be n plus 1 pi L, right? And we subtract Sn, so it is n pi by L. When you solve this, you will get pi by L, right? So now, in the next step, what we can do, we can replace 1 by L as delta S by pi. We can put this value, right? Now in the limiting case, let us take the limiting case when L approaches to infinity. When L approaches to infinity, what will happen to 1 by L? 1 by L will approach to 0, right? And in the limiting case, we know that summation gets converted to an integral, isn't it? So let us take the limiting case, and the function flx, when we take its limit as L approaches to infinity, so limit as L approaches to infinity, your flx will become the function fx, right? So now let us take the limiting case as L approaches to infinity, right? So now what are the changes that will occur? So first of all, this function flx will become the function fx in the limiting case as L approaches to infinity, right? Now look at the first function. The first function is 1 by L. So when L approaches to infinity, 1 by L will approach to 0. So this term goes to 0, right? Now, in the next two terms, we have a summation. So we can take the common summation out and we can write it as integral. The summation is from n equal to 1 to infinity, so I can write the integral from 0 to infinity, right? Then 1 by L, I know it is 1 by pi into delta S, so I can write here 1 by pi. And then we have, okay, let me write it as integration. You can check the limits, it is minus L to L, so it will become minus infinity to infinity. Then the function flx will become fx, and we have cos Snx. So in the limiting case, Sn will approach to S, right? So we are writing as Sx, then we have dx. This is the value, and then we have cos Sx. You remember we have delta S by pi, so delta S will become ds now, right, in the limiting case. Plus, so this common integral 0 to infinity is there for both the terms, right? So this summation is already taken out as 0 to infinity integral. Then 1 by L will become 1 by pi. Then the limit integral minus L to L will become minus infinity to infinity. Then flx will become fx. Then we have sine sx dx. And then sine Sx, and this ds integral will also come here because this is delta S by pi, right? So this is our total integral, right? So now let us rename these two inner integrals by as and bs, right? So I can write f of x is integration 0 to infinity as cos Sx ds plus bs into sine Sx d, right? So I can write it like this. So This integral representation is called the Fourier integral representation of the function fx. So this is called the Fourier integral representation of the function f of x, right? Now, from this Fourier integral representation, it gives rise to two types of transforms, that is Fourier cosine transform and Fourier sine transform, depending on whether the function is even or odd. So let us try to see this. How do we get the Fourier cosine and Fourier sine representations? So now, as we wrote that f of x was 0 to infinity as cos sx plus bs sine sx, and the common integral was depending on ds, right? Now let me quickly write the values of as and bs also for you. So as is basically 1 by pi integration minus infinity to infinity f of x into cos sx dx, and yeah, and b of s is, right, it is 1 by pi minus infinity to infinity f of x sine sx dx, right? Okay. Now, let us take the first case when the function is your even function, right? Now, what will happen when the function is even? When the function is even, let us look at these two integrals. Look at the first one, as. Fx is even, cos is also even. So even into even function is an even function. So in an even function, when the limits are from minus a to a, it becomes twice. So this will become 2 by pi 0 to infinity f of x into cos sx dx, right? And let's see what happens to b of s. B of s will become function is even, sine is odd. So even into odd is odd function. Odd function integration from minus infinity to infinity will become 0, right? So in that case, we can say that your function f of x is 0 to infinity. So you can see that this coefficient will become 0, and we will get here as into cos sx ds, right? So this is called the Fourier cosine transform for the function fx, and this becomes the formula for inverse Fourier cosine transform of the function, right? Now let us take the second case when the function is odd. When the function is odd, what will happen? In that case, let us take the coefficient as. Fx is odd, cos is even. So odd into even is odd. So in that case, as will now become 0. And now what is bs function? Fx is odd, odd into odd is even function. So this will now become 2 by pi 0 to infinity integral f of x into sine sx d. Clear? So again, and similarly, your fx will reduce to as is now becoming 0. So we will get 0 to infinity f of x, sorry, as is 0. So we will get b of s into sine sx ds, right? So again, this becomes the Fourier sine representation, the Fourier sine integral for the function fx, and this becomes the formula for the inverse Fourier transform of sine, right? So in the next video, I will be focusing on Fourier cosine and Fourier sine transforms. So now let us look into this video that what is basically the Fourier transform and what is the inverse Fourier transform for the function fx. So the mathematical formulas to calculate the Fourier transform is f of alpha is 1 by under root 2 pi minus infinity to infinity f of x e raised to power minus iota alpha x dx. So in this case, your input variable is fx, and we get out the answer in the form of transform, and that will come out in terms of the variable alpha, right? And the second formula is for inverse Fourier transform. So here the input variable will be the transform, that is f alpha, and we will have the coefficient along with it e to the power iota alpha x d alpha, and we have the constant 1 by under root 2 pi, and we integrate it from minus infinity to infinity. Now, there is an ambiguity in this constant. You will find that in certain books, along with inverse Fourier transform, they multiply 1 by 2 pi, and in Fourier transform, there is no coefficient, right? So just to eliminate the difficulty that where the coefficient is 1 by 2 pi and where it is not, so we have divided the coefficient 1 by 2 pi into both integrals as under root of 1 by 2 pi, and we have multiplied it in both the cases, right? So whenever you do a question on Fourier transform and inverse Fourier transform, you have to check in this point that where you are multiplying this coefficient, right? So if the question involves both Fourier and inverse Fourier transform, then there will be no ambiguity in the answer. But if there is only one part of the question that either you have to calculate Fourier transform or inverse Fourier transform, then your answer might differ if you refer to different books by this coefficient, right? So you need to take care of this point. So either you multiply the equal coefficient 1 by under root 2 pi in both the integrals, or you might see that Fourier transform, there will be no coefficient out, and in Fourier inverse Fourier transform, they'll multiply it with 1 by 2, right? Okay. So now let us look at the first question. You have to find out the Fourier transform of f of x equal to 1 by 2a if mod x is less than equal to a, and 0 if mod x is greater than e, right? That means how our function is defined. So this is minus infinity, this is plus infinity, and here somewhere we have minus a and plus a. So when mod x is less than equal to a, that means when x lies between minus a and a, the function is taking value 1 by 2a, and else everywhere the function is 0, right? Now I need to calculate the Fourier transform. So we will apply the mathematical tool Fourier transform. F of alpha is 1 by under root 2 pi, then integration minus infinity to infinity f of x e raised to power minus iota alpha x dx, right? Again, you can see that alpha is a dummy variable. You can replace it with omega, you can replace it with s, you can replace it with any alphabet of your choice, right? So now, according to the given function, we can divide this integral into three parts, and we can write it as minus infinity to minus a f of x e to the power minus iota alpha x dx, plus the second integral can be from minus a to plus a f of x e to the power minus iota alpha x dx, and the third integral will be from a to infinity f of x e to the power minus, I'll just rub this portion, so e to the power minus iota alpha x d, right? So you can clearly see that in this integral, the function is taking value 0. Similarly, in this integral also, the function is taking value 0. Only in the middle part, the function is taking value 1 by 2a. So let us put the values of the function fx. So 1 by under root 2 pi is already the constant that is out. When I put the value of the function 1 by 2a, 1 by 2a is also acting as a constant. So I can also take out 1 by 2a. And now I am left with the integral minus infinity to infinity e to the power minus iota alpha x dx, right? So now let us integrate it. So this is under root 2 pi, or I can write it as 2a times under root 2 pi. Now what is integration of e to the power minus iota alpha x? It is e to the power minus iota alpha x divided by minus iota alpha. limits from minus infinity to plus infinity, right? So now this becomes 1 by 2a under root 2 pi. Alpha is also constant, right? And now I am left with e to the power minus iota alpha infinity minus e to the power iota alpha, and this will become infinity, right? Upon minus iota. Done? Right. Okay. I think I made a mistake here. The limits are from minus a to plus a, isn't it? So the limits are from minus a to plus a. So again, I'll put in the limits. So this is a and this will become a, right? Okay. Now, what is this becoming basically? If you remember in complex numbers, you do this formula that e raised to power iota theta is cos theta plus iota sine theta, and you can replace theta with minus theta and you will get cos theta minus iota sine theta, right? Now when you add the two formulas, you can see that sine will easily get cancelled and you will get cos theta is e raised to power iota theta plus e raised to power minus iota theta divided by 2. Similarly, if you subtract the 2, you will get sine theta is equal to e to the power iota theta minus e to the power minus iota theta divided by 2 iota, right? So can you see that you are getting a similar expression here? If you absorb this minus sign in the numerator, this will carry a minus and this will carry a plus sign. So is it similar to what we are getting here? So I can write this as 1 by 2a under root 2 pi into alpha. So here I can write this term as minus 2 iota. I'll cross multiply it. And what is theta here? Theta is alpha a divided by minus iota, right? So you can see that 2 gets cancelled, minus iota gets cancelled. So finally, what are we left with? We are left with sine A alpha divided by A under root 2 pi, or you can write A alpha together. So we can write here A alpha into under root. So this becomes the Fourier transform for the given function, right? So I hope it is clear. Okay, let's proceed to the next question. So the next question says that you need to calculate the Fourier transform of fx equal to sine x in the interval 0 less than x less than pi and 0 otherwise, right? So now let's calculate the Fourier transform. So we know that f of alpha is equal to 1 by under root 2 pi minus infinity to infinity integral f of x into e raised to power minus iota alpha x, right? So again, according to the given function, the function is only valid in the interval 0 to infinity. So I can break up the integral. I can write it as 1 by under root 2 pi. The first break that I can do is minus infinity to 0 f of x into e to the power minus iota alpha x dx. Then the second break I can write as 0 to pi f of x into e raised to power minus iota alpha x dx. And the third breakup can be pi to infinity f of x into e to the power minus iota alpha x dx, right? Again, you can check that the function in this interval becomes 0 and again the function in this interval becomes 0. So only in the interval 0 to pi, the value of the function is sine x, right? So let us put up the integral. So your f alpha seems to be 1 by under root 2 pi integration 0 to pi, and then we have sine x into e to the power minus iota alpha x dx, right? Now, what is the easy method to solve an integral which is containing exponential and sign? since we saw that e raised to power iota theta is cos theta plus iota sine theta, so I can always write that cos theta is basically the real part of e to the power iota theta, and sine theta is basically the imaginary part of e to the power iota theta, right? So I have here sine x. So I can replace sine x as 1 by 2 pi, 0 to pi. I can write it as imaginary part of e raised to power iota x, right? Into e raised to power minus iota alpha x dx. So imaginary part I can take out outside because I can calculate the imaginary part of the entire integral later on, right? So I have 1 by under root 2 pi into imaginary part of the integral 0 to pi, and now I can integrate it. How? I can take out iota common. I can write it as 1 minus alpha x dx. Isn't it? I can write this term like this. And now when I integrate this term, it is easy to integrate. So I get 1 by under root 2 pi. Imaginary part of, what is the answer? We will get e raised to power iota 1 minus alpha x divided by iota 1 minus alpha. Limits from 0 to, right? Now when I put in the value of the limits, I will get 1 by under root 2 pi. Imaginary part of, what do I get? E raised to power iota 1 minus alpha times pi minus e to the power 0 is 1 divided by iota 1 minus alpha, right? So this can be further reduced to 1 by under root 2 pi. So I can take out 1 minus alpha outside, and then I have imaginary part of e to the power. So this term can be written as cos 1 minus alpha pi plus iota sine 1 minus alpha pi minus 1 divided by iota, right? Now you can multiply and divide by iota, so that will become 1 by under root 2 pi 1 minus alpha, and then we have to calculate the imaginary part of iota, and iota will become iota squared, that is minus 1, and numerator will become minus iota cos 1 minus alpha pi. Then iota and iota will become iota square minus 1, and there is already one minus. So it will become plus sine 1 minus alpha pi. And then here also we will get minus. So it will become plus iota, right? And now when I take out the imaginary part of this expression, it will become 1 minus cos 1 minus alpha pi divided by under root 2 pi into 1 minus alpha. So this becomes your answer. Okay, so this is a new technique where you can always replace your cos term with real part of e to the power iota theta and the sine term with imaginary part of e to the power iota theta. Right? I hope the question is clear to everybody. Okay. So now let us move on to another question. And now this question says, find the Fourier transform of fx is equal to 1 in the interval mod x less than 1 and 0 in the interval mod x greater than 1. Also prove that integration 0 to infinity sin x by x dx is equal to pi by 2. So now how to solve this? Let's see. First of all, the first part of the question is to calculate the Fourier transform, right? So how to calculate the Fourier transform? So f of alpha, I'm sure you know till now, it is 1 by under root 2 pi. So I'm not writing the formula now. So you can see that the function is only valid in the interval minus 1 to 1. So I'm directly putting the values minus 1 to 1. The function is 1. So we will simply have e to the power minus iota alpha x dx. Right? Now when I solve this integral, what do I get? This is 1 by under root 2 pi. Then integration of e to the power minus iota alpha x is e to the power minus iota alpha x divided by minus iota alpha. limits from -1 to 1. Put in the limits, so we will get 1 by under root 2 pi e to the power minus iota alpha minus e to the power iota alpha divided by minus iota alpha, right? So again, using the trigonometric relations, we can write this as minus 2 iota into sine of alpha divided by minus iota alpha, right? So you can see minus gets cancelled, iota gets cancelled, and finally we get 2 by under root 2 pi sine alpha by alpha, right? Okay. Now after getting this is the Fourier transform. Now the question is also prove that the integration 0 to infinity sine x by x dx is pi by 2. So you can see that the term is similar to sine alpha by alpha, only the letters are different, right? Variables are different. So there is an integration also here. That means you have to apply the inverse Fourier transform, right? Now when you apply the inverse Fourier transform, what will you get? You'll get back the function fx, right? So f of x is equal to the formula for inverse Fourier transform is under root 1 by under root 2 pi integration minus infinity to infinity f of alpha into e to the power iota alpha x. Now we have d alpha, right? So let us put in the values. So we have 1 by under root 2 pi integration minus infinity to infinity f of alpha is 2 by under root 2 pi into sine alpha by alpha into e to the power iota alpha x d alpha, right? F of x is equal to this term. Now you can see that only you need sine alpha by alpha in your integral and you don't need this term exponential. So what can you put x as? You can put x as 0. Now when you put x as 0, what will you get? You'll get f of 0. F of 0 means it will lie in the interval -1 to 1 and the function there is 1. So your left hand side will become 1. 2 by under root 2 pi can be taken out. So it will be 2 upon 2 pi. Integration minus infinity to infinity. You will get sine alpha by alpha. E to the power 0 is 1 and you will get here a d alpha. Right? Now, sine alpha is odd. Alpha is also odd. So odd by odd is a even function. And then this integral will become 2 times. So you will get pi is equal to 2 by 2 times 0 to infinity sine alpha by alpha d alpha. And this will give you that 0 to infinity sine alpha by alpha d alpha is equal to pi by, right? So here you can see that in a definite integral, the variables don't matter because you will simply put in the limits. So after putting out the limits, you'll get the value of sine alpha by alpha d alpha is pi by, right? So this is how we apply the Fourier transforms. So I hope it is clear. Thank you so much and have a nice day. Believe in yourself and you will definitely do it. And do subscribe my channel to get the latest updated video. Thank you.